Hello grade 12s and welcome to this video on the alkenes. Now an alkene that you may be familiar with is ethene gas, also known as ethylene gas, and it is used for the ripening of fruits and to blossom flowers early. So those are some of the uses of alkenes. In this video I'm going to show you how we can draw the alkenes and also how we can use the general formula to describe different alkenes. So over here we have a few questions from A. Olive's textbook on organic chemistry, and here they say that we need to draw the structural formula for each of the following alkenes and give the IUPAC name of each. Remember, the alkenes are those compounds that contain double bonds somewhere within their longest chain. So here we are given condensed structural formulae, and we're going to just do our best to get the correct structure using what has been given to us. We start off with the first carbon. It has 3 hydrogen atoms attached to it. So we draw in carbon with its 3 hydrogen atoms. Next to it we have another carbon, and all we know for now is that between that carbon and the first one, there needs to at least be one bond. Attached to that carbon, they say that there is a hydrogen atom, so we're going to draw in that hydrogen atom. Lastly, we have a CH2, so we're going to attach that with at least one bond and then draw in C with its 2 hydrogen atoms. Now remember, carbon needs to make 4 bonds. If we look at the first carbon atom on the left-hand side, it has made 4 bonds. But the second carbon has only made 3, and the third carbon has also only made 3. So we're therefore going to draw a double bond between the last 2 carbons, which now makes them the first 2 carbons when we name them or number them, right? But we do this so that all of the carbons have made 4 bonds. Now we can go ahead and name this compound. So this is the structural formula, the formula that shows the different atoms, how they're arranged and bonded. Now we're going to name this compound. We start off by identifying the longest chain that contains, of course, the functional group. We know the name here is going to end with ene, simply because these are alkenes. The longest chain here contains 3 carbons. And the stem name for 3 carbons is prop. So we write down prop. But we must indicate where the functional group is. And remember that we number our longest chain so that the functional group is given the lowest number possible. Therefore, we're going to start to number from the right-hand side, and we can say that this double bond falls onto carbon number 1. So we have prop 1ene. This over here is the name of this compound, prop 1ene, and as mentioned, we've drawn the structural formula as well. In some cases, your teacher or textbooks may tell you that it is not necessary to write down this 1 in between, and that is simply because in propene, the double bond has to fall onto the first carbon, and therefore this is an obvious case. But I am just including it just so that we can make 100% sure that we've done everything. You can see over here that I've drawn the molecular formula of this compound. The molecular formula only shows the types of atoms and number of each. It does not show how they are bonded to each other. Remember that the general formula of alkenes is given as CnH2n. In this specific compound, N is given as 3. So to calculate the number of hydrogens, we can simply say 3 times 2 because it says H2n. So 2n is going to equal to 2 multiplied by 3 because n is 3, and this gives us 6. And you can clearly see that the general formula works in this case because this is an alkene. Let's go on to the second problem where we are required to draw CH3, CH, CH, CH2, CH3. We start off with the carbon on the left-hand side, CH3. We're going to draw that in. Next to that carbon, we have a CH and another CH. So we're going to draw those, C bonded to an H. For now, we're just including a single bond between each pair of carbons. Then there is a CH2. So we're drawing a CH2. So let's change the pen. C with two H's attached to it. And lastly, there is a CH3. So we draw in the C with three H's. Now we're not done yet. We must always ensure that within our structural formula, each of the carbon atoms have made four bonds. The first carbon atom has made 4 bonds, but the second one from the left-hand side has only made 3. The third one has only made 3. The fourth one has made 4 bonds, and the last one has made 4 bonds. Therefore, the double bond must exist between these two carbons, ensuring that they have made 4 bonds each. This is the structural formula for this compound. Now we need to name it. We know that the functional group here is the double bond for the alkenes, and therefore the name is going to end with E. We identify the longest chain, and we see that it contains 5 carbons. So the stem name is going to be pent. We always number such that the functional group will obtain the lowest number possible, and to do so in this case, we're going to have to start to number from the left-hand side. So we therefore have pent 2-ene. Now that we've done this, there are no substituents, alkyl groups, branches, or halogen atoms, and this is the name of this compound, pent 2-ene. If you write out the molecular formula for this compound, you will see that the general formula will work in this case as well. And grade 12, this brings us to the end of this video on the alkenes.